Students, in this class we will learn about the most important library function, which is actually a built-in library function available in Python, and that would be learning about the math module. Now, in the math module we got scores of functions available to be utilized. Now it becomes important and imperative for anyone knowing Python to have a grasp of how and what these functions are. So when I say what, of course it's explanatory. What are these functions? And subsequently you need to know how. When I say how do you literally use these functions? So that's exactly what we're going to do. We are going to learn about this function first and then give an illustration as to how exactly we could utilize these functions in the real time. So having mentioned, without any further ado, let me start off with the ceil function. Now this is a very important function specifically for organizations. Now I'm going to demonstrate how exactly we could utilize this function and what exactly does this function do. So this function actually returns the nearest integer to the fractional number that is presented with. What exactly does that mean? For example, imagine an organization. Say for example, let me give you the basic example. Say suppose if you want to get math.ceil of say 9.4, right? I want this to be printed. So this is the line of command I've given, and I want to get the ceil. So let me run this. So I've already saved it and I'm running this. So when I run it, you see that I just mentioned to you, it gives you the nearest integer to the fractional quantity that is presented. Now where do we exactly apply this? I'm going to give a demonstration also where this can be applied. Now suppose you're working in a good company. When the salary gets paid, say the employee has to get a salary of say 5,690.9, say this is really basic, okay, say 90.10 cents. Imagine a situation is like this. So what do you think people will do? Let me just get the ceil of this. The employee salary is $5,690.10, and the payment has to be made. So I'm going to get the ceil of this. Print salary equals command math dot ceil of salary, right? So I've saved it and I'm going to run it. You see that it gives you the nearest integer. Instead of giving the employee 5,690.10 cents, the salary is 5,691. You are able to understand how this application works, because we cannot be giving cents and dimes to employee. Of course 90 cents, giving 90 cents is not much, but it also shows some level of respect, right, on the part of the employer. Of course 90 cents, people might say that 90 cents is small money. Of course it is small money, but if you were to give 90 cents to 9,000 people, then it's a different case altogether, right? But still, that 90 cents gives a rounded feeling to the employee who is getting the salary. So that is the small illustration how exactly the ceil function works. Okay, so let me comment this off. Now, having got that ceil, let me give the illustration for the next function. It's called as copy sign. Now, what does this function do? It's a built-in function available in the math module. Now, let me give an example of this copy sign. So I'm going to actually say print math dot copy sign of say 9 comma minus 3. Now, when I call this function, the value of 9 will be printed with the sign of the number 3. So I'm going to save this and I will show you what happens. You see that 9 is printed with the sign of 3. Now you might be wondering, where do I use this? Okay, let me give you this beautiful illustration of where exactly this particular function is used. Say you are designing an application for an electric car. Say you are designing an application for an electric car. Now this is a scenario, right? Let me give you the scenario. When the speed is say 60 miles and the gear, this gear has the ability to toggle. Say toggles, you can either say toggle stick or toggle gear, something like that, depends on what you like. Now in this toggle gear there are two options. The first option is drive and the second option is reverse. Now the driver wants to drive, or driver wants the car to move at 60 miles in the reverse gear, right? Reverse gear means the driver wants the car to move backward at the same speed, 16 miles. Now you might be wondering, what 16 miles, why is it really required? Now in the real time there are states, or I would say there are situations where it becomes required that the car has to move back at this rate. So there can be plenty of situations where you are driving. So imagine a bear jumps in the middle of the road, right? You have to go back, and at that time all you got to do in the electric car is to change the gear. In the electric car, it's not that you have to use the actual mechanical gear. That's a different scenario, but you will have to just press buttons, right? So the question is, if you have a choice, if you choose reverse, this data has to be passed. That's exactly is the idea. So I'm going to demonstrate how exactly we can do that. So with a small program, right? So I'm going to ask speed. Speed is equal to int, right? I don't need. I'm typecasting here just to be safe. Okay, please enter the speed. Right, this is the question. Please enter the speed. The speed is got, and then gear. Gear is equal to input. Please enter the gear. When I say gear, I'm actually pressing in the button, right? Please enter the gear. So in the gear, you can say forward or reverse. So this is actually got. Now, after getting these two things, I'm going to check if, instead of saying capital, I'll just say G. So if gear is equal to, say, reverse, gear is equal to reverse, what we need to do is I will actually give the following: outprint this is the action. The action is going to be math.copy sign, and it's going to be speed, comma, gear. Now I need to capture the sign, right? So in this case I need to say gear is equal to -1, or gear action. Then I'll pass it here, gear action. Okay, that's the code. So you need to place a comma here. Okay, that's fine. Now else print, I would just say, I'll copy that, else gear underscore action is equal to +1, and print this, right? So this is the app that would listen to the driver, and based on that it will actually send in this information. This information will be an input to the action that will be committed, right? But we are only dealing with one side. That one side is writing the code using the math operator. So that's fine. So I'm going to save this. So after saving it, let me run it. So enter the speed. The speed is 60 miles. Please enter the gear forward or reverse. I'm going to say reverse, and then you see that, please enter the gear forward or reverse. I've entered reverse, and the action is -60. When it says -60, the car will be moving backwards at the rate of 60 miles per hour. So this is a beautiful illustration how exactly we could use the math function. So having given you this illustration, it's time for us to move on with the next one. So we have finished seal, we have finished copy sign. The next is absolute number. So let me comment this off, and I'm going to show you the next sign. So the next function. So this is going to be returning the absolute value of a number. So this is called as fabs. This function is fabs. And what does it do? This will return the absolute value of a number. Now you might be wondering, why do I need this? Is it really required for me to enter an absolute to get an absolute value? Of course. Where do we use it? We use it when we are calculating area or mathematical problems where we do not require negative values. We don't need negative values at all. Sometimes it so happens we are forced to produce or perform an operation which will result in a negative value, but we cannot use that negative value. In other words, we don't want the negative value to be present, right? We need to get an absolute value. Now, for example, imagine this is a scenario. Imagine there is a person who has an account in a bank, and what he does is he withdraws all his money. He withdraws all of his money. Now he wants a, now there is a situation where he wants an overdraft. Now what exactly overdraft means? The bank will give you money, will give the person the money based on the trust he has built with the bank. Okay, it's all based on trust. So if the bank manager is happy with this person, he will give a overdraft. Now actually the overdraft is a negative value, okay, but we cannot display the negative value. This negative value is the information for the bank to understand, but when the customer is given this information, that information should be a positive value. So let's see how it goes. So I'm going to say overdraft borrowed or overdraft amount, something like that, is equal to input. Please enter the amount that the bank has given this person. Right, this is the amount. Now I will do typecasting because there might be a situation where we need to perform some arithmetical operations. So this is the amount that is being given by the bank. So current amount or current balance is 0. Current balance, you can simply say int input, say please enter the current balance of the client. So this is the current balance of the client. Now what we need to do is, from the current balance, this overdraft has to be taken out, right? Because he owes this money to the bank, but we do not know what's his current balance. Let us have this scenario, right? So we have to perform the calculation here. The amount owed to the bank is equal to current balance minus overdraft. This is the amount. Now we need to print here. Print you owe the bank this amount, right? And I'm going to display that. So I'm going to call this math dot absolute value, FABS, and then whatever amount owed by this person, owed to the bank, that will be printed there. Okay, so in this case, this is for bank reference. Bank reference is equal to amount owed to the bank, and then print message to the bank. So this message will not be visible to the client, so this is just visible to the bank. So message visible to the bank. And what is the message? The client has outstanding amount. So what is that outstanding amount? In outstanding amount, you got to give this bank reference. So this will not be visible to the client. So this is just for the bank's reference. Okay, so I'm just saving it. Now if I run this, let me run it and show the outcome to you. Please enter the amount that the bank has given the client. Say this client wants $5,000, so 5,000 is given. Please enter the current balance. Say current balance of this person is, say, $0. There's no money in his account. So clearly you see, message to the bank, the client has outstanding amount minus 5,000, and this is to the client. You owe the bank this amount, 5,000. You understand how this absolute value functions? So this is how it functions in the real time. But this application is not restricted to this example alone. There are plenty of cases where this would come into play. So this is just for your understanding. Okay, so having got this, let us go on to the next one. The next one, let me comment this off and give you this next application. So now we are going to talk about this all important factorial function. Now factorial function is very important, especially in data sciences, right? Without factorial you cannot do anything. Now why do I say data science? Because in factorial we got what is called as permutations, combinations, and a whole lot of statistical probabilities, right? This is a different area, probabilities. Okay, this is a different area of science. In fact, it has now become a full-fledged science. And there, without factorial notation, now in mathematics we represent it like this, exclamation. But in Python, the representation is different. And what exactly does that mean? If I were to say 5 factorial, imagine I'm saying 5 factorial. So what does 5 factorial means? 5 factorial is nothing but 5 multiplied with 4 multiplied with 3 multiplied with 2 multiplied with 1, which is equal to 120. This is how the factorial works, right? But 5 factorial is a small number. In statistics, we usually deal with big numbers, huge numbers. So in that case, we need a utility, a function which allows us to calculate that. So having mentioned that, let me just move on to show you how the factorial works. Now, this is straightforward, so I would like to keep it straightforward. Say, for example, you want to print the factorial of, say, 5 factorial, say 5, right? Now you save it and you print it. So you get 120. Now imagine you want the factorial of 6. You get 720. Now imagine you want to get the factorial of 10. You see that? See the number, how the number is increasing? Imagine you want to get the factorial of, say, 19. You will see the jump is huge. You see that? So that is the power of this particular function. It's a very powerful function, and we have to be glad that we are in a position to utilize this function. Okay, so the next function, specifically in Python, so that would be an apt way to say, because if we were to calculate 19 factorials by hand, we would just spend the next 2 days or 3 days simply calculating factorials, because we are not going to just be encountering one number. There would be several dozens of numbers that we would have to deal with. Okay, so having mentioned that, let me go to the next function. The next function is called as the flow function. So what does this do? This gives the greatest integer that is less than or equal to the number that is in context. Okay, so this illustration you will find it in the supermarket. Now suppose you have to pay, say, $21.23, right? And you do not have a change, so you give $100 to the teller. Now the teller has to give you the change back. It's not going to be easy. You cannot simply say as a supermarket that you pay me using a credit card, or you pay me using your, what do you call, the mobile wallet and stuff like that. Because as a supermarket, not everybody are going to be having credit cards, or not everybody are going to be having a mobile wallet, right? There is always the section of the society which don't prefer that. That's one situation. Number two is which are not in a position to use these gadgets and devices, right? One is the by choice, and the other is the inability, right? That inability should also be taken into account. There is that element of a big gap that has to be addressed. So as supermarket, we have to cater to everybody's requirement. So imagine a situation is like this. So the charge is $21.23, and the woman is paying, the young lady is paying $100. The teller has to give the change back. Now giving change back to one person, you might say, is okay. What big deal? The person can give in how much? 77 cents back. But imagine the situation. The person has to give for 10 people like that, or 20 people. In supermarket, at least 500 people, they will come like that. So what will be the situation? And not everybody are going to be paying cash. So that is also that element that is in place. So what we do is, as a supermarket, instead of taking the 23 cents, we design the application so that only $21 are taken. That is exactly what I'm going to show you here. So let me write a code for that. Okay, so this is the code for that. Code is amount spent is equal to int of input. This is going to be float, right? And over here, please enter the total amount spent by the customer. So this is the total amount. We are getting it. Now, amount received. So this is the received amount. So this is going to be int, or if you want float, you put in float. Input. This amount is got from the customer, right? Please enter the amount got from the customer. So this is got. Now we need to only give, or we need to take only the closest integer. So what we need to do is amount paid, to be paid, is equal to math.floor of amount spent. Amount due is equal to amount received from the customer minus amount to be paid. Okay, and then change due. We got to print the change due. So change, we don't have to say change due. We can simply say print change to be given back. This is equal to amount due, right? That's it. Story done. So this application will handle anything that comes in decimal format. So I have saved it. Let me run it. So if I were to run it, the customer is spending $23.21. Amount, the customer is paying $100. You see that change to be given back 77. You have to just give the customer 77, and the goods is rounded off to 23. Probably you can simply say the amount that has been rounded off, right? Print the price that has been rounded off is equal to, do a comma, and then amount to be paid, right? So you save it and you run it. This would be giving you much clarity. So amount, say 23, amount spent by the customer. Of course there is some check error, some grammar, I wouldn't say, some spelling error, vocabulary is there. I need to rectify it, but this is just an illustration. So I will do that if I'm developing a full-fledged application. Enter the total amount spent. Probably I will just change it. It looks a little bit odd. And enter the total amount spent by the customer. It's better. Grammar and spelling, we need to be careful when we're designing applications, because we are designing applications for the entire population of the world. So we need to take some efforts. Of course, there are situations where some little bit slight, typo error can occur, but we need to rectify them. We need to be straight in all these presentations. So having mentioned that, let me just move on. Okay. So I save it, I run it. So if I run it, 23.21. Amount got from the customer $100, and then you see that the price has been rounded off to 23, and change to be given back is 77. So that's fine. So that completes our today's lesson. So we will continue this class again, and this is the first part. The second part will follow on. Thank you. Welcome students, we will now continue our study on functions available in the math modules. Now in the last class we have already studied about the first part of the functions. We learned about the ceil functions, the absolute value function, copy sign function, the factorial function, the flow function. In today's class we will start off with the square root function. It's very important. Specifically, you want to perform any complicated operations, you need this square root function. So foremost I will import the math module. So after you imported the math module, I want to get the square root of say 36. So let me just give you this basic illustration. The square root value for 36 is equal to, you got to call the module math, the function sqrt square root, and what you want to get this 36. So you save it and then you run it, and it gives you this value. Square root of 36 is 6. Now what if you want to get the square root of 729? And I'm going to pass this value 7 to 9, and then I'm going to run it. So clearly you can see the square root of 7 to 9 is 27. How about 1024? The square root of 1024, you save it and you execute it, you get 32. So these are some of the illustrations where square root comes into play. Now I would like to comment this off, and then we will look into the next available function, what is called as the power function, POW. Now I want to know what is the value of 3 raised to the power of 3. Now this is nothing but 3 multiplied 3 times, that's going to be 27. Okay, this is simple to handle, right? But what if I have 3 raised to the power of 30? Can I just utilize expressions in the way that I've just shown you here to calculate the value of 3 raised to the power of 30? It's going to be Herculean. It's not going to be all that easy. That's one case. Second case is that time consuming. Time is lost, energy is lost, and if time and energy is lost, then everything is lost. So this is a powerful function, and let us see how to execute it. I want to get the value of 3 raised to the power of 3, and that is equal to, so first we will call the module math.pow is the function, and give the base first and then the exponent, and then you save it and you execute it. So 3 raised to the power of 3, this is 27. So if it is 3 squared, then the base first and the exponent is followed. So you save it and it's 9. As I mentioned to you, what if you wanted the value of 3 raised to the power of 13? So the base first, then the exponent, you save it and then you execute it. You see that this is the value. It is imperative to understand. Now with the advancement of technology, we would have to perform calculations of greater order. Please remember that. Now, performing mathematical operations has a direct connection with technology advancements. Have that in mind. No matter what you want to do, if you want to perform something, if you want to create something, there will be a calculation involved. Without that, you cannot just erect systems. So having mentioned that, we need all these functions. No matter which area of expertise you are planning to get in, you will have to require these functions. So having mentioned that, in case if you want to get the base being changed, say I want the base to be as 10 and I want to get 10 raised to the power of 10. So go over here, give the base as 10 first. Maybe I will just change the exponent to 12, so that you can have some level of distinction here. So base is 10 and it is raised to the power of 12. You save it and you give it. Right, the button is fired, and then this is the value you get. Okay, so we have seen 2 important functions. So let us keep moving on. Now this is the next function. This is the exponent function, or you can identify it as e raised to the power of x. This is a very important function, specifically when you want to study growth. It can be any growth for that matter. Specifically in today's world, you have so many sicknesses and diseases that are being affecting plant species, animals and human beings. So suppose somebody has got some sickness, and exponential growth is compared to the rate in which the disease advances. And similarly, you have logarithm, which is actually the reverse process of exponents. And this is not only available in case of disease and sicknesses, but exponential growth can also be seen in many areas. Say for example, you want to study the growth of a certain channel on the social media. Either it would be connected with an exponential growth, or it would be connected to an exponential decline. So 2 cases are always possible. and it can also be the growth of a company. So having mentioned that, we need to know the value. Now it is imperative to understand, if you give the value of E, if I'm printing the value of E, let me just give you the value of E. So print the value of E is equal to, you have to call this function, right? So first the model math.exp of, when I'm using E, I give it as 1. I want to get this value, so you save this and you run it, so you can get the value there. It's 2.718. so the value of E lies between 2 and 3. So this is the value, right? Now what if you want to get the value of E squared, right? So what you need to do, you go here, probably what I'll do, I will print it in the next line. I go here, I want to get the value of E squared, so I save it and then I print it. So the value of E squared is this. Now what if you want to get the value of E raised to the power of 3? Now these are all different growth levels, right? Now this is the growth. First day you can attribute it like this. See, the very first day the channel has got so many views. The next day a certain social media channel has got so many views. This is the third day. You can give the fourth day, say E raised to the power of 4, and place the value 4 there and save it and run it, and this is the fourth day. And probably the fifth day, just give 5 there and then change the value here, 5, save it, and this is the fifth day. These are all feasible values, right? And similarly, this can also indicate the growth of a certain company. In the first year they have this turnover profit, it can be millions. The second year this is the turnover, third year this is the turnover, fourth year this is the turnover, and fifth year this is the turnover. So these are all some of the real-time examples. And also the logarithmic values are there. So what I will do is I will also give certain examples for that. So having given you that, let me move on to the logs. Now there are actually two types of logarithms, right? Now one type is log, it's called as common log. This is called as common log. The other type is called as natural log. Now natural logs, they work on a base E. The base is equal to E which we just studied, and common log, their base value is 10. Now please remember, a log can have any base, but whenever the base is E, we call it as natural log. So have that in mind. So now what I'm going to do is I'm going to be giving you an illustration of a log which is to the base 10. Now I want to get the value of log 10. So when I say log 10, the base is actually taken as 10, right? So log 10 to the base 10 is equal to 1. So that is the value. Now let me just go to the calculator and show that to you. So this is the calculator. Now is there a log there? Okay, log, I'm going to give value of 10 there. So 10 is there and I take log. You see that? This means this log which I'm utilizing is actually taking the base to be as 10. That's the reason log 10 to the base 10 is equal to 1. Now if I want to change the base, there are some procedures I need to follow here, a little bit tight procedures. So that's the reason Python comes into play, right? So Python is a very sophisticated and powerful language. So with that we can do a lot of things. Okay, so in this case, suppose if I want to get the value of log 2, You see that 0.3010, that's a log 2 value, and the log 3 value will be 0.4771. Okay, all of these are in base 10. So having given you this, let me just show you how to get the, so print the log of 10 is equal to, so I'm calling the math module and the function log, and I have to give you the logarithmic value, right, followed by its base. This is important. So when you save it and run it, you see that you get 1. Now you want to get the log of 2 to the base 10. You save it and you run it, you get this. This is the same value we got in the calculator, and change it, you get it to log 3. You save it, you run it, you get the value of log 3. Now if you do not give the base, now you see, you don't give the base, you save it, you see that this is the value you are getting. In this case, say for example, if I'm going to give log 10, log 10 should be 1, the base is not given, so you save it. So this is the value I'm getting. Now this is actually giving us log to the base e, right? So I have that in mind, and having mentioned you that, now you can actually utilize this base 10 in another way. Now just now I've given you, say for example, you give e there. Let me save it and run it. It is giving me an exception. E is not defined. So the value of e, I'm going to take e is equal to math.exp. I'm going to define e in this fashion, e, and then now you will see the value changing. You see that instead of saying log 10, the value, or I should say the log of e is, this is the output, the log of e is 1. Why is it 1? Because the base is e here, so that's the reason it's 1. Now if I'm calculating the log of 2 to the base e, so this is actually represented in mathematics like this, ln of 2, and in this case I need to change the value ln of 2, and I'm running it. So ln of 2 is this is the value for ln 2. The base is e, and if you were to change it to 3, this is going to be ln of 3, and you save it and run it, so this is going to be the value. So two important logarithms I have demonstrated. One is log to the base 10, the other is log to the base e. Now if you want to utilize simply log 10, right, you can also utilize that directly. So you can go over here, and I just want log 10. So I can simply say print, and then the value of log, this base is 10. So if I want to simply get log 2, what I need to do is I call the module, math module, and the function log 10, right, of 2. You save it. So you remember what did we get for log 2? Let me clear this off. Log 2, this is the value that we got, log 2, because it's to the base 10. That is the value that we should get here. You see that? So this is another way that we can call on the log 10. So this is log of value 2 to the base of 10. Okay, so we will move on to the next illustration to learn about other available functions. So having given you that log, we can also move on to important trigonometric functions. Now, in trigonometry is a powerful field. I know that you are aware of it. Now, what is the main advantage of trigonometry? Now, many of the questions that you are solving in geometry can be solved by using trigonometry. Now, there are people who would love geometry and there are people who would love trigonometry. And it is imperative to understand trigonometry gives you a very faster approach. Have that. The same question which you face in geometry can be solved using trigonometry in a faster manner. So we need the following important values in trigonometry. Now, they are called as sine, cos, tan, and cosecant. I say secant, then cosecant and cot. Now, what are these? These are all trigonometric ratio, right? Now, without these ratios, you cannot handle any practical problems, any practical applications. So in architecture, you need these things. Now, why do we need these things? Because these ratios are built using the right triangle, and any given figure can be split using the right triangle. Now, why do we need right triangle? Without right triangle, we wouldn't be able to solve any geometry questions, right? Any geometry questions, if you want to solve a geometry question, you need to have a right triangle, and subsequently using right triangle, you have the all important Pythagoras. The most important theorem is the Pythagoras theorem when it comes to applications. So, having given you this brief insight, what I'm going to do is I'm going to show you how to exactly utilize these values, the sine value, the cos value, and tan value. Now, let me go back to the calculator and show you the following. Now, if you want to get the value of, say, sine 30, the sine 30 value is 1 over 2. So you can see there is a trigonometry tab there. Just press sine, you get 1 over 2. Fair enough. Now, if you want to get the value for cos 60, let me clear it. Cos 60 is also 1 over 2, 0.5, right? And so on and so forth. So there are many angles that we would have to get the values for. Now, what I'm going to do is I would like to get the value of sine 60 or sine 30. So print the value of sine 30 degrees is equal to, how do we do that? We call the module and then sine, and you open the parenthesis. Now, if you give directly 30 degrees, it's not going to work. Okay, I will show you why it's not going to work. I'm going to save it. Let me see the value. See the value it's given, and see the value that we got for sine 30. So I'm going to take 30 here, and sine 30 is 0.5. We need to get 0.5, but we are getting something else. So how do we exactly do that? Now, we need to know that pi, if I say pi, I hope you know how pi looks. Pi is nothing but 180 degrees, and if I want to write 30 degrees, I can write 30 degree as 180 degree divided by 6. That would give me 30 degrees. So I need to follow a similar representation over here. But in this case, the representation is different. I cannot use 180 there. I got to use this all important math.pi, call this pi from the math module, and divide it by 6 because I want to get the value of sine 30. So you save it and you run it. You see that? 0.4999, which is nothing but 0.5. Okay, So that is how you handle the sine function. Now imagine you want to get cos pi. Now let me just go to cos pi. Now this is all important value for cos to check it out. Now before I could go to cos, I would like to give you one important value for sine. That is sine 90. Now sine 90 is 1. Let me just go over here and get sine 90. So for that I need to call the pi and divide it by 2 and then run it. So you see that this is not sine 30, this is sine 90. Let me run it one more time. So the value of sine 90 is 1, and that is exactly what we got here. Okay, having got that value, let me go and show you something about cos. So I'm going to clear it up. Now let me see what is cos 30. I'm going to click on cos 30. This is the value I'm getting. This value I'm getting because cos 30 is actually root 3 divided by 2. Now if you go here, just remember this value 0.866. Now I'm going to get the value of root of 3 divided by 2, and you see that this is the value you're getting. This is exactly the value of cos 30 in fraction quantity. And how did we get it? We got it by this all important value. Root of 3 is divided by 2. So that is the understanding we need to have here. So let me go here and type cos and go to math, and I want to divide it by 6. I save it and I run it. So what do I get? You see that? This is the value that we got here, the same value. So cos is working. Now let me go and give 180, cos 180. What is cos 180? Negative 1. I should get that negative 1 there. So in this case, go over here and one small corrections. It's not a correction. I should change this to cos 30 and let me save it and run it. So the value of cos 30. Okay, so this is the complete output. Now I want to get the value of cos 180. Now cos 180, as I mentioned to you, is negative 1. I should get this negative 1. So I need to produce cos 180 here. So how do I get that? So math.cos 180, I save it. Then I go here, I run it, I get negative 1. You follow me? So that is so for cos and for sine. Now we need to go to the all important tan. Now let me show you a basic value for tan. Now tan 45, that should produce me 1. You see that? So that's exactly what I'm going to show you here. Now if I were to take tan 90, tan 90 is going to be undefined. If I go over here and I click on tan 90, you see that? It says invalid input. So I'm going to check this out. I'm going to check these two things out. And the third thing is, what is the value for cot 90? You gotta know that, right? You can also try that value, cot 90, and say cos tan 60. You can also get the value of tan 60. Tan 60, this is the value. Okay, so let me check this out. Tan 45, tan 60, and tan 90. Tan 60 produces me 1.732. Okay, so I go over here, I change it to tan 45, and I call upon tan and math pi. To get 45, I need to divide by 4, right? So that's exactly what I'm doing. I'm going to save here and then I run it. So tan 45 is 0.9991. That's 1. That's fair enough. So now let me try tan 60. So I call upon tan 60. So this has to be divided by 3 and then I save it. This is the exact value that we got, right? 1.732. Now let me go to tan 90. As I've shown you, tan 90 has produced me an invalid input. So let me see what math function here is producing me. It says value of tan 90. Tan 90 is actually a value that is tending towards infinity, right? Tan 90 is sin 90 by cos 90. Sin 90 is 1, but cos 90 is 0. So 1 divided by 0 is moving towards infinity, and we are able to produce this value here. So that's so much so for tan. So I haven't given you those values for tan, sine and cos. I think this is a good place for us to stop before we move on to the next set of functions available in math modules. Thank you, students.